So this is a resource track paper. So I only have 5 minutes, but I will try my best to make it clear. This paper is a joint paper. The first also is a research, is a visiting PhD student, and I'm the last author. Here's the outline for my talk. First, I will give an introduction. I will talk about what is the meal recommendation and what's the dilemma of a meal recommendation research and what are the existing meal recommendation data set available. And then I will give a very brief talk about construction of the meal REC dataset plus dataset. I will talk about the construction process, give you a discussion about data analysis, and also will show you some experimental result on the meal REC plus datasets. In particular, I will give you the result for the personalization and the healthiness and about how to improve the healthiness of the recommendation. Finally, I'll give you the contribution and the future work. So, as you can see that here is a very simple but typical meal course. So we have a three course meal, okay? But for sure, we can have a 10, 15, maybe even more. I remember after World War II, Churchill and the British Prime Minister and Stalin and the American President, they meet together in somewhere has maybe 30, 40 course, okay? Eating for whole night, but eating too much is not good for health, okay? 2 of them actually, they all die relatively early, okay? So the first one we can see that it's an appetizer, and then it's the main course, and then it's the dessert, okay? For sure, we can make it more complicated. For example, many European people like drinking wine, beer, all kinds of alcohol. Also, you can extend it, but in here we make it very simple, okay? So what is the meal recommendation? So meal recommendation is a very typical healthcare related recommendation. It will provide user with meal consisting of multiple courses from the different category. Beyond the accuracy, healthiness is also very important. There are some relationship between the user, meal, and the courses, which you can see shown in this picture. So you can see that it's a meal on the left side and the course on the right upper right side and the user on the bottom side. This is very similar to the information retrieval typical problem, document, query, and the user. Okay, so user usually is the most complicated issue if you try to model the user. But relatively, the mail and the course or the document query is relatively easy. Okay, but for sure there are lots of problems inside. Okay, so for the dilemma of the mail recommendation system, so traditional way is we try to separate interaction learning. Okay, so for example, we build the user representation. We construct the user representation and then try to learn the user course interaction learning. Just talk? Yeah, okay. Sure, okay. And we also try to can build a meal level at the meal level. We build a user profile and found the correlation between the user and the meal. And for a little bit complicated one, that's the one we're presenting here is about cooperative interactive learning. So what does that mean? Means the meal course affiliation act as a bridge to connect the interaction of the two separate view. So for example, we try to include the user course interaction learning, and that's from the one view. The other one is okay, and the other one is we try to build the user meal interaction view. So because the lack of the public available meal recommendation dataset with the meal course affiliation, explore the impact of the cooperation between two levels of interaction is a constraint. So what we did is we here is the existing meal recommendation data set, as you can see. The problem is if you try to collect the existing real data, usually it involves the privacy issue. If you try to build from the experimental environment, that will cause, for example, eating meal cannot be repeated many times in a day, and collecting in is time consuming. So what we are trying to do is we build our own data set, which involve 4 steps, like data preparation, dining session simulation, and collaboration based on the interaction mining, and also the healthcare measurement. And we also did some data set analysis, which you can see from here. We conduct some experimental results on personalization in terms of the recall at K, NDGG at K, KK 20, 40, and 80. So I'm only giving you the conclusion because I have the time limit. So separate interaction learning of the different level interaction performs differently. And the cooperative two different interaction learning is a proper way can effectively improve the accuracy for recommendation. For the result of healthcare, we use 2 healthcare scores. One is the mean healthcare score, the other one is the position aware exposure gap. And the result we found is without healthcare oriented guideline, the baseline model usually follow the user's last health preference and make the last health recommendation. That's very easy. When you go to restaurant, you like the oily fried food, you like the meat, normally not healthy, but human like those kind of unhealthy food, okay, in usually case. And we also did some experiments about how to improve the healthcare recommendation. For example, we use 2 measurement. We found that 2 post-filtering measure can improve the healthcareness, but also hurt the personalization. So we need to do the balance between healthcare and the personalization. We need to have some kind of trade-off. So the conclusion is that first, we propose a meal recommendation data set which fit the data gap. And also, we conduct some experiments with different setting, and we establish some baseline for the future research. And this paper provide new resources which provide some useful insight using AI for the good in the food domain. And there are some future work. You can look at the paper for detail. Regarding the data set, it is available online, so people can look at it. And if you want to use it, feel free to download it or contact me. We can have more discussion. And acknowledgement. That's it. How much time?